guys. So yeah, nice to see so many people. So the entire purpose of my talk is basically to wake you up. So by the time Vitalik talks, you are in the best mental shape, able to digest everything. This is just a joke. You don't have to wake up. So yeah. So I'll start asking you guys a question, just again to wake you up a little. Raise your hand if you know what product market fit means. Okay, some people know. So it's a very simple thing. It means that if you have a startup, then you have to iterate your startup until you get users, and actually preferably paid users. And if you don't do this, your startup basically dies. And the actual term product market fit comes from the internet bubble times. So there was this internet bubble in 1999. People had lots and lots of money, even more money than Ethereum ever had. And then there was a crash, the bubble crashed in 2001, and suddenly people didn't have any money. And startups actually learned things like 4 out of 5 startups die. You have to do something, you have to find users. At that time, Google almost died, so it was a pretty tough time in 2001. But then things appeared like lean startup, there was Y Combinator. People started to learn that actually, if you get users, and preferably paid users, you don't have to have so much money. So the entire different philosophy was born where if you have a startup, you stay frugal, you save money, and you basically change things until you get users. So if we look at Bitcoin, for instance, and ask the question, does Bitcoin have a product market fit? The answer is yes. And the reason for this is that, the value of Bitcoin is to actually store the value of money and to save for retirement. Bitcoin is slow, which doesn't really matter for it because it's supposed to hold lots of money, and gold is heavy. It doesn't hurt gold in any way. In the same way, the fact that Bitcoin is slow doesn't hurt Bitcoin. So Bitcoin does have a product market fit. But let's take a look at Web3, right? Another question to you guys. Raise your hand if any of you have a Web3 application on your phone now and you're using it. Okay, I don't actually, but you guys have. So there are some early adopters, but you don't really see people in public transportation and subway playing Web3 games. You don't see people using like DeFi much. So all of this stuff is still very experimental, I think. And it's a little sad because this number here says 8, right? So we're like at least 8 years spent and we don't really get so much adoption. And so the question is why is it happening? Why we don't really have so much of this Web3 thing? And there are 3 things which actually are required, which are missing. I would say number 1 thing is privacy. If you pretty much take any Web2 application and you're trying to port this application to Web3, it's impossible to do. Even in a simple example, if you have a bank or if you have an e-commerce store, there are private things, right? If you order from Amazon, then your order is private, the money you pay is private, the same with your bank, right? You don't want to show people what's inside of your bank account. And Ethereum doesn't really have privacy, and because pretty much all other blockchains since Ethereum just copied Ethereum basically, there's no blockchain which has privacy, and we've been a little bit stuck for the last, I would say, 8 years. There's no privacy, there's no security. Security means that people feel safe, like the hack that happened like just several months ago with this poor guys that like lost $1 billion, sent it to somewhere else through Gnosis. This would actually never happen with Web2. You don't hear people in a regular bank being sending like $1 billion and not getting this $1 billion back. So the security is missing, and the reason the security is missing is because in regular banks, in Web 2, security is provided by humans, right? Ultimately, if something is wrong happening with your bank, your credit card gets blocked, and then you call the guy and the girl, and they actually unblock your credit card. So the security is actually achieved ultimately by humans, and blockchain doesn't have humans, right? So on blockchain, people feel unsafe. And then last thing is agentic, this kind of a interesting word, but what it basically means that a blockchain is passive. It doesn't really do anything for you. If you have your bank can send you, can have a Python script, and the Python script can send you an SMS message, so to authenticate all kinds of stuff. If you have a trading account, you can run a Python script on your trading account to trade. All of these things are missing from blockchain, again, because blockchain is passive, and because pretty much everything copied Ethereum doesn't have it, so no one has it. Blockchain is decentralized. So we basically have the thing where Web 2 has a product market fit, but it's centralized, and Web 3 does not have a product market fit. People just don't use it. It's still experimental. So most of the Web 2 applications, you can just take a very simple one, just even like a web store. It's impossible to port it to Web 3. So in effect, Web 3 doesn't exist much. And at Scale, we've been working for the last 5 years as layer 2 for Ethereum. We have lots of transactions. We have about 3 million transactions per day. We have almost 20 layer 2 chains, which are Ethereum compatible chains. But at some point, we started to feel that we essentially got stuck. There's a constant set of problems, this privacy, security, and agency things. Every time we talk to a customer or someone would want to do Web3, they had these problems and people were getting stuck. So we kind of, for a number of years, we were trying to kind of stay the way, but ultimately there was lots of discussions in our team, and we decided to kind of try to fix these problems. Essentially go our own way, our independent way. We still love Ethereum, but we just want something more exciting, I think. So we decided to start our own layer 1, which is called FAIR. We actually have it running now. The phase 1, we started the internal testnet and gave access to the testnet to our partners several days ago. So we're running this layer 1, and the entire team is kind of very excited about this. I'm going to talk about FAIR and what we're going to do with it. Essentially, it's Ethereum plus, and the 3 things which we want to fix is privacy, security, and agency. And we just want to fix them in a sane and fast way. We don't want things to go forever or like have a plan for the next 20 years. We want things to be solved reasonably fast. And so we need to solve the 3 things. And the privacy we are solving using encryption, something which we call proof of encryption. Essentially, FAIR is the first blockchain that is able to hold encrypted data. All other blockchains just have public data. We have encryption. It's pretty hard to do, but I'm going to talk about this a little later. We're going to have security, and security means that you somehow need to match the humans that exist for Web 2. There are no humans, so pretty much the only way you can do security for Web 3 is AI. And essentially, even ChatGPT-2 could probably prevent like 99% of existing attacks. Like the guys that sent $1 billion to their own address, this would be easily prevented by ChatGPT-2. It's not so difficult to avoid human errors for the AI. So we need AI and we need agency. And an agency, there are several ways we are going to do it, but the realistic way and fast way to do it is through trusted execution environment or something which is called SGX. Okay, so first I'm going to talk about privacy. We have 4 phases for the protocol, something which we call BIDE. And I take the credit for inventing this backronym BIDE, blockchain integrated threshold encryption. I did it using ChatGPT. So, and ChatGPT came up with this pretty nice acronym, I think. And it's kind of a more mathematical acronym. We're also calling it proof of encryption. The idea is that you want to actually encrypt things on blockchain. But then the question is, how do you encrypt? Because on blockchain is not a person, or it's not a single entity. So there's not like a public key of a blockchain. Turns out there is an encryption algorithm which is called threshold encryption, where you essentially encrypt to a group of people or nodes, something actually very similar to multi-sig, but multi-sig is for signatures and threshold encryption is for decryption. Basically, what you have is that you have this jigsaw puzzle. So you encrypt to a public key, but when you decrypt, you need to have a supermajority of nodes in the network, 2/3 of the nodes, and each of them decrypts its piece of the jigsaw puzzle, and then 2/3 of them get together, they glue together the pieces, and then they actually have the actual decryption. It's a pretty cool process and means that you need to have, if you have 2/3 of the network honest, any single or small group of bad validators, malicious validators cannot actually do bad things to your encryption and decryption. So we're using this for privacy. And phase one of Byte protocol is actually provably eliminates MEV, which means that when you submit a transaction, the transaction is encrypted. It doesn't really actually break the Ethereum compatibility. It's just a small JavaScript library. You encrypt the data field of the transaction, and then basically the people don't see the transaction until the transaction is in the blockchain, and just before it's executed by the EVM, the transaction gets decrypted using threshold decryption. It's a pretty cool process, and actually you can prove that there's no MEV. So you take any smart contract, you take Uniswap, you take Aave, you take things like Polygon, like prediction markets, and you don't change any smart contracts. The blockchain stays the same, but things magically become MEV free because the transaction is in the pending queue in the memory pool encrypted, and by the time it's getting decrypted, it's actually already in the blockchain. It's impossible to front run or analyze or MEV, whatever. Yeah, so that's how it works. It's a very simple slide, actually. Basically, you use Ethereum as your you used to use it, but then there's, as I mentioned, there's like small JavaScript library, and you encrypt your transaction, and then it goes through all of the Ethereum stuff, and then we have a provable consensus, and the provable consensus actually, as the last stage, just before EVM execution, decrypts the transaction. And it actually sounds easy, but you need to have a very detailed specification for the consensus to do it, because you know that the problem with consensus is always it can get stuck. It also can get kind of desynchronized. The state can be different on different nodes. So you are taking a consensus and you plug in this another pretty complex thing, which is threshold decryption as the last stage, and it doesn't have to break it. But you have to have for this really, really mathematically defined consensus. And we were lucky that we're using consensus, which we kind of compiled from academia, and all of our stages of consensus are mathematically defined. So we were able to actually plug in this threshold decryption part. And then it's magically MEV free. So we're working now with our partners and friends to essentially port MEV DeFi applications to this new chain, to Fair. And if any of you guys are interested, we'll be happy to work with you on this MEV-free protocol. Again, this is actually like I was trying to use ChatGPT to create an illustration for our protocol, and then we have a really talented engineer, and he said, this ChatGPT is really ugly. I'm gonna draw it, and he drew this. So it's a pretty cool thing. It's probably hard to understand every single detail, but the basics is that you have a Ethereum transaction, you have the to address, you have the data field, and you encrypt the things. And then they go through all of the Ethereum mechanics through the consensus encrypted, and the transaction is committed to the blockchain encrypted, and then the last moment the EVM decrypts the transaction. It actually works. So there's this life cycle, as I mentioned, you submit, you encrypt, add to pending queue, encrypt it, and then ultimately proposal is finalized, committed to the chain, and then at this last moment, this last stage, you have execution by the EVM. Before execution, you actually decrypt. You use the Chef's code decryption. A committee decrypts using over the network using a super majority. And you have lots of interesting use cases for MEV-free blockchains immediately. You definitely have MEV, things like Uniswap. By the way, actually, there was a really great talk before this, my talk about MEV. I can only say that MEV is one of the reasons we have so bad adoption of decentralized exchanges. Most people use centralized exchanges because just the exchange rates are so much better, and they are better because on centralized exchanges you don't have MEV extraction, and centralized you do have it. So, and also you have lots of spam on chains coming from these MEV guys. So, but in addition to exchanges, you have lots of other things, applications of MEV resistance like games, prediction protocols, whatever. Now, this is phase 1 is already running. The phase 2 is something which we are working on now, and that's where you actually can decrypt. You have encrypted data, you can decrypt it on demand. So the smart contract can say here's the data, and the smart contract says decrypt. And this is how we will do it on fair in Solidity. Basically, there will be a precompiled contract, and you will just pass the data at any time, and it will get decrypted. And then, why would you want to use it? You know, this is kind of a computer science exercise for some of you guys that are interested. Why would a smart contract want to decrypt things, right? And the easiest thing is actually the rock, paper, scissors game. And it's just for you to think about this. Why would the rock, paper, scissors game need to decrypt at the same time? The reason is that when you do this, like rock, paper, scissors, you actually reveal at the same time. So the smart contract essentially collects stuff and then decrypts at the same time. It's super important and cool, but the real application is more for things like DeFi, because with encrypted things, you can have encrypted bids, for instance, for auctions. So you can have auctions where people submit encrypted, sealed bids, and then at the same time, atomically, they get decrypted. Now, lots of other applications. Byte protocol phase 3, and that's where we are actually adding the re-encryption, something to share data. That's really important for things like social networks, for instance. You have your data on chain, but you want to share it with someone else without sharing it with the entire world. So this is this cool thing which is called re-encryption. You don't decrypt it, but you add the public key of this new person to the encryption keys, and then this new person can also decrypt. And you can do things like Google Docs. This is how it's going to look in Solidity. And then you can do things like Google Docs. You can do literally like Web 2, like social networks, where you share information with people you like Instagram, maybe Twitter. I think on Twitter everything is public, but Instagram, Facebook. And then collaborative document editing, like Google Docs, for instance, when you share documents. And lots of interesting other things. You have this confidential gaming. Pretty much with public blockchains we have now, it's impossible to do any reasonable game. If you play poker, you don't show your cards to other people, right? So with private data, you're able to fix pretty much everything when you need private data. You fix things like you have an e-commerce thing, and then you want to encrypt the orders. And the last phase, which is the hardest, is the doing mathematical calculations for things like on-chain banking. And this is the hardest thing. You need to use things like threshold, fully homomorphic encryption. And there you can do things like you have a bank, your data is encrypted, and then you want to do a tax on this data, taxes. And then you can selectively do a mathematical computation without decrypting the data. Lots of interesting things here. Now, this is the encryption, proof of encryption thing. The second thing about product market fit is security. And this one we're actually solving by adding AI agents to the blockchain. And there are two important things. Smart contract deployment. When you deploy the smart contract, the decentralized AI can actually analyze the smart contract and assign the security score. And then transaction execution, like the guys with 1 billion thing. When you execute transaction, AI can actually look at it, look at the score of the smart contract, and talk to the user to actually explain to the user whether the transaction is secure or not secure, actually providing this like a trusted agent. Last thing is agency. Yeah, and agency we are actually doing using trusted execution environment and SJX. That's it, pretty much, guys. So lots of use cases. We are working on FAIR. You know, all of you are welcome to join our community. We are going to launch this layer 1, also move the existing SKALE chains to FAIR. Thank you so much.